Hi friends, good morning, welcome to Gate Academy. Good morning Prachi, good morning Narendra, good morning Chandradeep Rai, hoi, 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 hoi. Fine. So hope you're having a nice day. Already one dislike, huh? 7 watching and 1 dislike, huh? It's okay, no issues about that. So what we were discussing today, we'll be discussing traffic signals. Till now, if you remember in the traffic engineering, I have started with traffic characteristics and then traffic studies and analysis. Traffic studies and analysis, we have seen origin and destination studies, traffic volume studies, spot speed studies, accident studies. After that we have seen some relationships and all the other things we have seen. Now we are coming to the output. The output generally we see is traffic signals. So traffic signals, generally the traffic signals, if you talk, I will try to explain this in a simple way. So generally what type of colors you will see in the traffic? You will see green, amber, red. If I am designing a two-phase system, let us say, then generally there will be green color, green, okay, two-phase system or phases. Generally you will see the at the intersection you will see the at the intersection we will try to see I mean we'll try to design the signals, or we'll try to see we generally see the signals at the intersections, right? So at the intersections we try to, we see the signals. Here we try to design the signal systems. Generally two-phase signal system or two-phase signal system means you are designing for a traffic like this, right? It is a traffic like this, or traffic going in the other two directions. Fine. So let us say if there are two signal systems, then two-phase signal system, this is one phase and this is another phase. If I am talking about two-phase signal system, then this is called one cycle. This whole thing is called cycle length of A. This whole thing is called cycle length of, this whole thing is called cycle length of A. This is cycle length of A, this is called cycle length of B. So that means let us say you are going in a certain direction. Initially you will be shown green, and after that it will be showing amber color. Amber means yellow or orange, whatever that is. Next it will be showing red. This whole cycle is called, this whole thing is called one cycle. Approximately this whole thing is called one cycle. Fine. When there is green in one direction, there will be red in the other direction. When there is green in one direction, there will be red in the other direction. And when there is green plus amber in one direction, there will be red in the other direction. So in a simple words, I'll explain you what exactly is phase and what is through phase, what is through traffic, what is turning traffic, and all those things. But in an approximation I am saying all these things, right? So one cycle length is generally time in seconds. If I call cycle length, what exactly is cycle length is it is time in seconds. It is time in seconds for one full length of indication. For one full length of indication, it is time in seconds for one full length of indication, that is cycle length. Fine. Or indirectly, it is the time interval between initial green time and next time when green occurs. Next time when green occurs. So that means one cycle length, if I have to talk, it would be green plus amber plus red. One cycle length would be green plus amber plus red. So generally it is you will measure the time over here in the seconds, because in the signal systems also you will see that it is 120 seconds, 60 seconds. You will not see like 1 hour, 2 hours. Okay. So green plus amber plus red approximately 120 seconds. It generally varies from 50 to 200 seconds. Okay. So this is the cycle length. Now what is meant by green time? Green time is the time interval for which signal shows green color. So the name itself says green time. It is the time interval for which signal shows green color. Simple, the name itself says. Next one is red time. It is the time interval for which signal shows red color. It is a time interval for which signal shows red color. In the green color, that means there will be movement. In red color, you have to stop. In between these two things, there is one more color that is called as amber time. Amber time, I can simply say it is the time interval for which it shows amber or yellow or orange color. But what exactly is the moving? Green color means you can move, red color means you can stop. But what is meant by amber time? Amber time is the time during which either you can clear the intersection or you have to stop. Are you getting it? It is the time interval. Provided in such a way that driver either clears the intersection or stops before the intersection, or stops simply, either clear the intersection or stops. No, the one of the at least one of the options should be available for the driver. That means let us say when driver is just after the green time, just after the green time, just after the green time, the color changed to amber, and if the vehicle is here, if the vehicle is here, he can clear the intersection. That means before the green time, the amber time changes to red time, the person here can clear the intersection. And if person is somewhere here, if person is somewhere here, or if the driver is somewhere here, if driver is somewhere here, once the green color changes to amber color, then what he feels is, okay, I have to apply the brakes. So he'll apply the brakes, he'll just come before the intersection and he'll stop. He'll not clear the intersection. Are you getting it? The first thing is when driver is here, he will clear the intersection, or if the driver is here, he'll come and stop. This region between these two things, this region between these two things is called as or this zone between these two things is called as dilemma zone. This is, I'll call this as some DS, I'll call this as some DC. Fine. This zone between DS and DC is called as dilemma zone. C represents clearance, C represents clearance, S represents stopping. C represents clearance, S represents stopping. So DS means indirectly it is stopping side distance only. Like, you know, he has seen that the color has changed to amber, and then he has to apply the brakes so that he'll come and he'll reach, he'll go away from the intersection. This zone between DC and DS is called as dilemma zone. Our main idea is to avoid this dilemma zone. Why? Because if he is in dilemma, then what happens? He'll just go and he'll struck in the intersection. If he is struck in the intersection, then what happens? There might be accidents or there will be traffic jam and all those things. Either you have to clear the intersection or you have to stay back. But you should not be in a dilemma that whether to clear the intersection or whether to stay back. If you are in the dilemma zone, then you will be struck at the intersection. Idea is to clear the intersection. Fine. So, any doubts in this, you can ask me. Shashi Tech and Non-Tech, good morning. Only 7 people are watching. Please do like, share, subscribe. 3 people are disliking me. It's okay. What can I do then? Any doubts, guys? No doubts? Fine. So now how we will avoid this dilemma zone is, if let us say this is DC and this is some W, and total vehicle has to cross this, right. Total vehicle has to cross this, and length of the vehicle I will take it as some L, this is some L. So, you have to design the amber time in such a way that this total distance is crossed, right. That means speed multiplied with time is the amber time, is equals to dc plus w plus L. This total distance is to be this total distance is to be traveled, and idea is such a way that there should not be any dilemma zone. There should not be any dilemma zone means, that means dc should be equals to ds. That means you should be in such a position that when you see this amber color, if you accelerate it, you will clear the intersection. If you apply the brakes, you will stop before the intersection. So, that means in order to avoid the dilemma zone, dc must be equals to ds, right. So, in order to avoid dilemma zone, dilemma zone, dc must be equals to ds, So, what you can write from here, v into t equals to ds plus w plus L. Fine. From this amber time, t is what? Amber time equals to ds plus w plus L upon v. So, the speed generally we will take it as 85th percentile speed. This is how generally we design amber time. Amber time. In order to avoid dilemma zone, dc must be equals to ds. So, v multiplied with t equals to ds plus w plus L. So, amber time is ds plus w plus L upon v, where v is the 85th percentile speed. Any doubts in this? You can ask me. Only 7 people are watching. Please do like, share, subscribe with as many people as possible. Fine. So, we will try to solve a question. A driver is traveling at a speed of 50 kilometers per hour. A driver is traveling at a speed of 50 kilometers per hour, was seen crossing an intersection, He claimed that duration of amber display was improper. Consequently, a dilemma zone exists at that zone using the following data. Determine whether the driver claim was correct or not. determine whether the driver claim was correct or not. Determine whether the driver claim was correct or not. Reaction time is 1.5 seconds, amber time is 4.5 seconds. Reaction time 1.5 seconds, amber time 4.5 seconds, reaction time 1.5 seconds, amber time 4.5 seconds. Width of road 15 meters, length of vehicle 4.6 meters. meters, acceleration 3 meters per second square. Acceleration 3 meters per second square. Please try to solve this question. Good morning, Akash. More dislikes here. What happened? Good morning, Aviral Patli. Sorry, I don't know how to spell your name. Good morning, Aviral. So, these are the things that is given to you from this. Try to find out whether his claim is correct or not. Speed of the vehicle is given to you initially. Prachi, read the question properly. Speed of the vehicle, a driver is traveling at a speed of 50 kilometers per hour, and there are 4 dislikes now. Wow, why why people are disliking me suddenly? What went wrong initially? What went wrong today? झूठा बोला ड्राइवर ने, ठीक है, we'll see how exactly things goes. Whether the driver claim is correct or not. So for that we have to calculate amber time. We have to calculate amber time. How we will be calculating? Am I audible, guys? Is there any problem? Am I audible? So amber time, how exactly we will calculate? If you remember, it is ds plus w plus L upon speed v. ds is equals to ssd. ssd, how you will calculate? Vt plus v square upon 2gf. V is given as 50 kilometers per hour. V is given as 50 kilometers per hour. Reaction time is given as how much? 1.5 seconds. A is given to you, acceleration as 3 meters per second square, right? So F is not given to you, A is given to you. If you remember, F equals to A upon G, right? So A equals to F times G. In the brake efficiency test, we have proved this, A equals to F times G. So if I keep it over here, D equals to, or ds equals to ssd equals to 50 kilometers per hour. 50 kilometers per hour means, in meters per second, it is 50 multiplied with 5 upon 18 meters per second. What is the value? So that equals to 13.88 meters per second. So substitute everything. ds equals to ssd 13.88 multiplied with 1.5. 13.88 multiplied with 1.5 plus 13.88 square upon 2 into G into F, that equals to 2. Answer would be 1.5 plus 68.99 meters. That is ds, and amber time T would be equals to ds plus w plus L upon v. So 68.99 plus w is 15, L is 4.6 upon v. V is 50 kilometers per hour, that is 13.88. So amber time required would be amber time required is 6.38 seconds. Amber time required is 6.38 seconds. Amber time required is 6.38 seconds, right? Any doubts? A is given as 3. Okay. Okay. So if A is 3, then what is the value? $13.88 multiplied with 1.5 plus 13.88 square divided by 6, 52.93. Calculation mistakes, don't repeat this calculation mistakes. 52.93 meters, 52.93 plus 15 plus 4.6 divided by 13.88. So you will be getting approximately 5.22 seconds. This is amber time required. Amber time required. This is amber time required. And what is the amber time provided? This is amber time required. And what is the amber time provided? Amber time provided is 4.5 seconds. That means what? Less amber time is provided. If less amber time is provided, there is dilemma zone, and whatever the driver that he claimed is correct. Some people said that his claim is wrong, but his claim is correct. Amber time required. Amber time required is more than amber time provided. Amber time required is more than amber time provided. Amber time required is more than amber time provided. So dilemma zone exists. Driver claim is correct. Driver claim is correct. So driver ने गलत नहीं बोला. So drivers are correct compared to that of engineers. We engineers go theoretically, drivers say practically. Fine. Any doubts in this? मेरा 4.22 आ रहा, क्यों आ रहा आपको? Only 6 people are watching. I don't know how. Then if you don't know how, please try to correct your mistakes. There might be some calculation mistakes. Any doubts, guys? Any doubts? This is not conventional, Narendra. Why I am discussing all these things with you is so that your concepts will be very much clear. I would have directly discussed like that Webster's method and I would have gone, but anyway since these type of problems can be asked in prelims, that's the reason I am discussing in this, like writing and all those things. Because this problem can be solved in a matter of 2 minutes actually. It has to be solved because direct application of formulas, but anyway I took time for the explanation, that's it. Any doubts? No doubts, fine, thank you. The next one is interval. Next heading is interval. This is the time between this is the time interval. This is the time interval when signal changes from one color to another color. When signal changes from one color to another color. This is further divided into two types of intervals, that is change interval change interval or amber time. Change interval or amber time. Change interval or amber time. So, what exactly is meant by change interval or amber time? It is the time period, amber time, which we have already discussed. It is the time interval between green and red. When the color changes from green to red, there is a time interval where I mean, there is a time interval which is used to provide either for clearance of intersection or for stopping of the vehicle. That interval is called as change interval or amber time. So, this is generally provided. This is generally provided. It is generally provided after. This is generally provided after green time, after green signal. This is generally provided after green signal. Next one is clearance interval. Clearance interval. It is provided. It is also called as all red time. It is also called as all red time. It is also called as all red time provided after amber time, provided after amber time for clearance of all the vehicles for clearance of all the vehicles at intersection, for clearance of all the vehicles at intersection, for clearance of all the vehicles at the intersection. That means generally if you see, I will provide green, I will provide amber. After amber, I will provide a zone which is also called as all red zone. Then once again, I will here also there will be sorry. Amber. Fine. So, there will be green A, amber A. Fine. Here there will be red zone. This will be red A. This is red B. Okay. So, this zone is called as all red zone or clearance interval. Sir, why this is provided? Why this is provided is after amber time there is a possibility that at the intersection here some vehicles may get struck. Some of the vehicles may get struck at the intersection. So, what we will do is at all the signals will show red only, so that whatever that is struck at the intersection will be removed. Generally, you do not see this, but this type of all red time is also given. The name itself says clearance interval. The name itself says what? Clearance interval. So, that is also called as all red time. Fine. This is clear. It is generally provided after amber. After amber, you will see all red time, which is also called as clearance interval. So, there are two types of intervals. First one is change interval, which is also called as amber time. Change interval, which is also called as amber time, and next one is clearance interval, which is also called as all red time. There will be green B, there will be amber B. After amber, there will be once again all red time here. Okay, there will be once again all red time. This is all red. Fine. So this is all red time and this is also all red time. Okay. Any doubts in this? Any doubts in this? Only 6 people are watching. There are 4 dislikes here today. That means my past videos, I think yesterday video, is there any problem in the yesterday videos? Like, I have discussed something about engineering services and I wasted half an hour of time. I don't think so, it's just waste. I have given you some ideas. Fine. So this is amber time. Next one is initial amber time. Sometimes initial amber is also provided. Initial amber. It is sometimes provided. It is sometimes provided as get, set, go. Before green interval, before green interval or before green signal, before green signal. It is sometimes provided as get, set, go before green signal. That means if let us say there is green, there is amber, this is red B, this is red A, this is green B, this is amber B. Before green, I'll provide an amber, that is called as initial amber. Initial amber, this is for get, set, go. That means suddenly if it changes from red to green, the person, like, he can't suddenly move. He'll use some amount of time to perceive that, then to put the acceleration, then to clear the intersection, right? So before that only it is an indication that shows that next color is green color. So after red color there will be an indication that will be showing that, that is also called as initial amber. That means you just get ready, next there will be green color, you keep your leg on the accelerator, get, set, and suddenly once it goes to green, go. This is called as initial amber. Get, set, go. Fine. So this is initial amber. Okay. Generally we don't use this, but anyway, it is provided after before green interval. That means from red to green, if it is changing, after that it will be generally provided. Here also it will be provided. I am just not showing it here. After every red to green it is provided. Fine. I have not shown all red time here. I am just showing initial amber. Okay. Any doubts in this? You can ask me. Yeah, I should not be worried about anything. I should not be worried about views. I should not be worried about likes. I should not be worried about anything. I have to take only classes. Then, these guys will be more worried, these guys will be more worried because there is no proper, approach to the people, and if they don't get to the GATE Academy, whether it is offline courses, online courses, then it will be a problematic for these guys. If it is problematic for these guys, then it is problem for me also. Fine. Anyway, keeping all those things aside, coming back, so what we have discussed green interval, we have discussed red interval, we have discussed amber time, and then we have discussed change interval, clearance interval, and then we have also discussed the other things, right? Change interval, we have discussed clearance interval, and then we have discussed initial amber. Now coming to something called phase. In a basic simple words, I am not giving any definition here. In a basic simple word, or how I can define a phase is green time plus change interval plus clearance interval Very simple. Green time plus change interval plus clearance interval is considered as one phase. So whenever I am saying two phase system or one phase system means this is phase 1, I can say. In phase 1, like signal system is at the center, it will be showing green, when this is showing green, vehicles will be moving like this. This is phase 1. What would be the phase 2? Or I will show both the phases here. Two phase signal system, whenever they are saying two phase signal system, whenever they are saying two phase signal system, how exactly it will work is, two phase signal systems so this is phase 1. In phase 1, this is phase 1. In phase 1, vehicles in this directions will move, and in phase 2, vehicles in this directions will move. This is two phases. This is phase 1, this is phase 2. Okay, this is phase 1, this is phase 2. That means initially when green color is shown over here, vehicles will be moving like this, red color will be shown in this direction and after that red color will be in this direction and green color will be in this direction. Fine. So this is two phase signal system, phase 1 and phase 2. This is two phase signal system. So green time plus change interval plus clearance interval is called a single phase. So this is one phase, this is other phase, this is two phase signal system. This is generally provided when straight traffic, when through traffic is more than turning traffic. I am not showing any turning traffics over here, right? So when you can take a note over here, you can take a note is when through traffic is more than turning traffic, when through traffic is more than turning traffic, then two phase signal system is generally provided. Two phase signal system is generally provided. Two phase signal system is generally provided when through traffic is more than turning traffic, then two-phase signal system is generally provided. Now four-phase signal systems, there is another system called four-phase signal system. Four-phase signal system. So when both the traffics, when through traffic and turning traffic both are significant, then we will generally provide four-phase signal system. This is one phase. This is another phase. This is another phase. This is another phase. Four-phase signal system. So when through traffic and turning traffic both are significant, when through traffic and turning traffic both are significant, then we generally provide four-phase signal system, something like this. And turnings also, left turning will create less conflicts compared to that of right turning. That means left turning less conflicts, whereas when there is a right turning there will be more amount of conflicts, means accident points. So generally we try to avoid right turnings. The best design system is to avoid the right turnings or conflicts. So if you are able to, like this rotaries, flyovers, all those things are provided. Just one thing, that is to avoid right turning traffic. Okay. So this is four-phase signal system. You can take a note over here. Note is four-phase signal system is generally provided when through traffic and turning traffic both are significant. When through traffic and turning traffic both are significant. Four-phase signal system is generally provided when through traffic and turning traffic both are significant. Fine. So next point is left turning traffic. Left turning traffic is generally preferred as there will be less conflicts. Next one is right turning traffic. Right turning traffic is generally avoided as there will be more conflicts. Fine. So any doubts up to here you can ask, okay? Now the dislike increased to 5. I think Narendra is the one who not understand. Sujit, what is your doubt? Sujit, what is your doubt? Sujit is saying that he is not understanding anything. What is your doubt? Narendra is saying there is no doubt. I think Sujit is the one who is the fifth one who disliked that he didn't understand anything. It's okay, whatever the doubts if you are having, please go ahead and ask, and you can ask me in your own language also. This is Gate Academy Global, that's the reason I am teaching in English. So you can ask me your doubts in any of the language that you are comfortable with. So don't worry about it, and yeah, it's okay. I'm not starting my own channel or anything. I am just right now doing it over here only in this platform. So please do like, share, subscribe, and so today I think we have discussed only some basics, but these basics are very important to tomorrow whenever I say design a two-phase signal system, four-phase signal system, three-phase signal system. So accordingly you should be able to understand what exactly is meant by the phase and what is green, amber, red, clearance interval, change interval, all red time, initial amber, all those things. Fine. So yeah, tomorrow there is a launch of Gate Academy Global PDGD course, so that's why we are working on it. So we have some works on it, and yeah, from day after tomorrow I'll take 2 hours of classes. Till tomorrow we'll be taking only 1 hour of classes, so please do support us. Till that time, this is Karthik Mandalapu signing off. Bye bye, have a nice day. Bye. Have a nice day, guys.